Okay, in this video we're going to go through how to do the various different types of lens diagrams, both for convex and concave lenses. So the first one we're going to do is we're going to do a convex lens. So I'm going to put little titles at the top telling you which one is which. So this one is going to be a convex, and it's going to be past 2f. Okay, so past 2 times the focal point. So I've already measured out here for you for these model ones where the focal points are, so where the focal points are and where 2 times focal point is, because that becomes important for when you're looking at the size and the type of image you are producing. So first off, because it's a convex lens, I'm going to just quickly draw in the middle to remind myself that it is a convex lens, as opposed to, like on this bottom one, we're going to do a concave lens, which is going to look like that. Okay, so you just got those in the middle just to show which type of lens it is. So if you do this on an exam, that might be already drawn for you, and that'll tell you you're going to draw a convex lens. So my object is going to be, I'm going to draw it 5 centimeters from my vertical axis. Okay, so 5 centimeters from, and the vertical axis shows you where the lens is, so that's where the lens is placed. Okay, so I'm going to do 5 centimeters from there, and I'm going to make it, let's say 2.5 centimeters tall. It's 2.5 centimeters tall. So for my object, I'm just going to draw an arrow 2.5 centimeters tall. Right. So now we get to the bit where we've got to show what we do, and there's only 2 things you need to remember for this. There's 2 lines that you need to draw. The first line needs to go straight through the centre of your lens. So straight through your principal axis and your vertical axis where they meet. Okay. So where these 2 axes meet is the centre of your lens, and one line will show how a light ray would travel if it goes straight through your lens. And I'm going to draw that as long as I need to. Just so I know that where I meet my lines together, I'm definitely going to meet somewhere on this line. So it's going as long as possible to give me the best chances possible of making sure it does meet. Then my second line is going to go parallel to my vertical axis, my principal axis, sorry. Okay, so straight across to my lens, and then it's going to go through my focal point F, because the focal point is where every line will meet. So if I do one line going straight across and then through my focal point, it will show me where my image is going to be produced. Oops, there we go. So my image is then going to be produced where these 2 points meet. Okay, so I'm going to get an image produced here. So here I've got my object, and over here I've got my image. Now I can look at these 2 things and I can tell myself something about these. So I'm going to write up in this top corner here that's empty the things I know about these. So first off, number 1, I can tell this is real, and that's because it's produced on the other side of the lens, which tells me I am going to be able to project that onto a screen. Number 2, it is inverted. So that tells me, and you can see this, it's upside down. So the image is the opposite way around to the object. So you're asking first question, is it real or virtual? So real would be on the other side of the lens, virtual would produce on the same side of the lens, so you can't produce it on a screen. And number 3, is it magnified or is it diminished? Okay, so let's measure them just to check. So this one was 2.5, and this one is 2 centimeters, so it is diminished. So this happens anytime you have an object past 2 times the focal point. You end up with a real inverted image that is diminished. So we could work out as well how many times that is diminished. Okay, so you can work out the magnification of this. But we'll do that on one later when we look at one that's bigger. Okay, so we'll look at a magnified one and we'll look at how many times it is magnified, because that's more likely when you're going to have to do it. But it's the magnification equation that you should already know. Okay, so moving on to my second image that I'm going to draw. So this time I'm going to be between f and 2f, so between the focal point and 2 times the focal point, and this will give us a different type of image produced. So I'm going to measure this time from my from my vertical axis, along my principal axis. I'm going to go 3 centimeters. Okay. And then I'm going to do another object. I'm going to keep the objects the same sort of height so you can see what's going on. So I'm going to do another 2.5 centimeter object. So again, just top that with a little arrow so I can see, and I'll label that my object. So this time, again, it's a convex lens, so I'm going to draw my convex lens on there. And again, I'm going to do exactly the same thing as I did before. So I'm going to start from the top of my object. My first line is going to go straight through the middle, going all the way across. My second line is going to go again parallel to my principal axis and then through my focal point. Okay, and we can see my image is going to be produced over here. So this is going to be my image. So this time, what do we notice about the image compared to the object? So again, is it real or virtual? So it's on the opposite side of the lens, so it's got to be real. Is it inverted or upright? Okay, it is inverted, because again, it's flipped upside down. So this is like your retina, both of these, so your retina in your lens in your eye, this is like the image produced on your retina. So the lenses in your eye flip the object upside down, so the image on your retina is upside down, so you see things kind of upside down. Your brain has to then deal with that and flip it backwards. So this time though, if we look, the image is actually 4.5 centimeters-ish, okay, compared to the 2.5 centimeter object. So this time it is magnified. So it's not diminished this time. So we can see that as we move the object, if you took an object and you moved it from beyond 2f to in front of 2f, it would go from being diminished to being magnified, the image. Okay, so by moving something closer to the lens, we're actually magnifying it. Okay, so that's the two for convex lenses we're going to do right now. We'll come back to these at the end, and we'll have a look at magnification on these. So I'm going to move on to a concave lens, and then I'll have a look at if we get closer than the focal point next. Okay, so a concave lens works a little bit differently. Okay, I'm actually going to draw my object in the same position I did on the previous one. So I'm going to go 3 centimeters. So just there, 3 centimeters. Again, same height. Go 2.5 centimeters up. Okay. So this time, your first line is going to be exactly the same. The one going through the middle. Now, the reason for this, if you think back to refraction, where this is hitting the lens, it is not going to be refractive because it's going directly through the centre of the lens. So it's going to end up, the light rays are going to end up hitting the lens at 90 degrees, so along the normal line. So they're not going to be refractive, so they're going to go straight through. So it doesn't matter what type of lens you've got, basically. But with a so far, and again, same thing. So for the next bit, we do parallel to the principal axis, up to the lens. Now, so far, we've been going through the focal point and producing an image down here somewhere. But this time, this is not a convex lens where the lens focuses this way, okay, and focuses in and converges the light. This time the light's going to diverge, so the light's actually going to go off somewhere up this direction, and it's going to go up this direction from the focal point. Okay, so the light's going to actually go up here like this. So I'm going to use this focal point on the same side of the lens as the image. But obviously, these two lines are never going to meet on this side. Okay, they're not going to meet on this side. It's not going to produce an image on the other side of the lens because they're diverging from each other. But what does happen is you can get a virtual image produced on this side. So I'm going to continue with a virtual line. I'm going to show that with a dotted line. So this isn't real. Okay, so I've got a dotted line on this side, and my image is going to be produced here where these two lines meet. Okay, so I can draw this line here and draw my image there. So sorry, I'll label these again. Now, if we have a look at this image, so first off, is it real or virtual? Now this time it's on the same side as the lens, so it is going to be virtual. Number two, is it going to be upright or inverted? So this time it's upright. And number three, okay, it is smaller than the object, so it is diminished. So this is a concave lens, so this is pushing the light outwards, diverging the light, and therefore the only place we can form an image is a virtual image on the same side of the lens. So this is never going to be able to produce this on a screen, because if you shine light through this lens, the screen over on this side where you would put the screen, the light just doesn't form together, it doesn't focus. So yeah, we've got a diverging light, and that therefore your image is going to be produced virtually on the same side as the object. Okay, last one I'm going to show you then is if we have an object which is closer to the lens than the focal point. So I'm going to get quite close, just in front of the focal point. I'm going to go. Let's go. Don't want to get too far away. Yeah. So if we say 2 centimeters, no, let's do a little bit more. So let's go 1.5 centimeters away from the lens. Okay, so 1.5 centimeters away from the lens. I'm going to draw my object a little bit smaller this time because I want to make sure this fits on the page. So I'm going to draw just 2 centimeters. Okay, and we'll see what happens. So object, let's not forget to label it this time. And this time again we've got a convex lens. So the concave lenses, the reason I've just done one of those, they're always pretty similar. You're less likely to get one of these because they all end up the same. You always end up with an object that ends up like this. Okay, whereas you can see there's a big difference, and you'll see on this one, between the convex lenses, depending on where you put the object. So, like I said, last one we're going to do when you've got the object closer than the focal point. So this time, again, it's exactly the same starting point. We do a line straight through the centre of the lens, as far down as we can go. And then we also do a line parallel to the principal axis. And then, because it's convex lens, we're going to converge the light this way. But we should notice that these two lines are now not coming together. They are not focusing together. Okay, so the way we can solve this is again by looking at virtual lines. So what we do is we follow both of the lines backwards. Okay, so we follow the lines up here. So I'll do dotted lines to show the virtual lines again. This might end up quite big. Okay, and we'll see where they end up meeting. So they end up meeting over here. So my image is produced here. So because I can't join these two lines together, I follow them back and see where they would meet if they were a virtual image produced. So this time, again, looking at our images, we've got one. It is a real image this time. Oh, so it's not, it's virtual. Sorry. So because it's produced on the same side as the object, can't produce on a screen, it's virtual. Number 2, it is upright. And number 3, it's clearly a lot bigger than the object. So it is going to be magnified. So this shows you how, again, moving. So you could get a question like saying, an object is moved from here to here. Okay, you could have two objects drawn on your diagram, and it'd say what happens when the object is moved from 3 centimeters away to 1.5 centimeters away, and you would say it goes from being real to being virtual, it goes from being inverted to being upright, but it remains magnified. Okay, so they're both magnified, something like that. So you need to look at comparing where it is to each other. You need to get used to what these images end up coming out like. Okay, last little bit of this that you need to know is to do with the magnification. So you should be able to calculate the magnification for each of these now. So I'm going to show you this one, and then you can work your way back through the rest of them. I don't think this is a particularly challenging part of this, and it's something you've done plenty of times in biology because you're talking about when you're looking at objects through a microscope. So magnification equals your image height divided by your actual size. Same equation that you use when you're looking at like a cell or something like that, and you look at the image compared to the actual, tells you the magnification. So for our one here, our magnification equals our image height, which is, I think, 7 centimeters. Yep, so you can see it's 7 centimeters. Right, image height divided by our 2 centimeters that we got for our object height, our actual height. Okay, so our magnification, if you actually divide those by each other, gives us 3.5, I think. Just check. Yeah, 3.5. 3.5 times bigger. Okay, it's 3.5 times. So it's magnified by 3.5 times. So you can go through, you should be able to do these quite easily. So go back through and work your way through all of these. So for each of them, what I want to see by the end of it is, and then also for the practice ones that I'm going to give you, you have drawn your lens diagram. So same principle for each one. One line straight through the centre, one line parallel, then through the focal point, and then decide do you have to go backwards or can you just produce an image on the front like these ones. Once you've done that, tell me, is it virtual or real, upright or inverted, magnified or diminished, and then once you've done that, work out the magnification. If it gets smaller, obviously your magnification is going to be like less than 1, because 1 times magnification would mean that you are producing an image exactly the same size. Right, so once you've done all these, there should be some practice ones for you to do as well. Really do need some practice with these because they are actually quite simple to do once you're used to doing them, but you have to get used to doing them, and you have to just kind of not forget those simple little things that we have to do.